Good evening or afternoon, everyone. Since nobody out there in TV land really knows when we're recording this, it could be 8 o'clock in the morning for all you know, which that's usually when Prateek and I are drinking. As always, we are your hosts. My name is Daniel Vacanti, and with me is my friend and colleague
Prateek Singh.
Prateek Singh. It's customary to start off with a listing of the whiskeys, with the what is the Festivus? The airing of grievances, right? So we're going to be doing the airing of whiskeys. Do you want to go first?
Yep. I'm back to the Glendronach at 7 sherry cask, 57.9%. It is so pretty.
Assuming we have a way of leaving comments, please, everyone, please leave comments on the dearth of whiskeys that Prateek has. I think we've only done, what, 6 episodes, maybe 7 episodes, and this is already your second or third repeat?
That's my second repeat. That's my second repeat. Yeah.
For shame, for shame. Having said that, I'm not sure.
Limiting my whiskeys in progress.
Yeah, whatever. Yeah. There's no such thing as whiskey in progress. So having said all that, I can't remember if I've done this one or not. I hope it's not a repeat, but this is hopefully everybody can see that, an 18-year-old Dalmore sherry cask strength, as always. Everybody out there should know I generally only drink single cask strength stuff. And this is 51.7%, so not too terribly high. Again, that's probably kind of showing because of its age. Sherry cask. Let me pour mine. Did you say yours is a sherry as well, right? Did you say?
Yeah, it is. It is.
That's Glendronach, so it must be.
It is. Oloroso and Pedro Jimenez.
All right. So, cheers, everybody. Stanjava. Today, again, assuming that we're doing these videos in order, just because in the interest of full disclosure, we haven't really published any of these videos yet, but assuming that we're doing them in order. As we mentioned in the last video, this video is going to be more about ideas around how to prioritize value, prioritize by value, and economic frameworks for discovering value, et cetera, specifically something called cost of delay. So I think what we're going to do is we're going to talk a little bit about what cost of delay is, because there's a lot of misinformation out there. A lot of people say cost of delay, but I'm not sure that they really, they don't really mean what they think that they mean when it comes to cost of delay. So we'll get into what hopefully a fairly rigorous definition of cost of delay, how you can use cost of delay to help understand value or optimizing or maximizing value, and some pitfalls that you might run into. That will set us up for a couple of other presentations that we have, or videos that we have coming up. So anything you'd like to say before because I'm going to be doing a lot of talking here to start us off. So Prateek, this is going to be your chance to get a word in edgewise for the next 10 or 15 minutes or so. Do you have anything?
Now or for the next 15 minutes, hold your peace.
Mm-hmm.
Yeah, no, I do have to say it is very pervasive. The cost of delay has caught on really quickly in the Agile community. So it just does seem like everyone's picked it up, and I will say it might be better than some of the things people were doing before, but I'll leave the rest of it to you.
Okay, so I am going to, if I can, share my screen, and I'm going to ask you, Prateek, to let me know if we are good. Is this showing up okay? All right. Yep. So we brought visual aids this time. So I just want to talk through a little of this, because it really does help if you kind of see this more visually than us just sitting here waving our hands like we normally do. By the way, was that Farticus in the background that was barking? Is that what you're
Yeah,
muted?
it was. I tried to mute it, but
So
he's going a little crazy.
All right. Okay, so what is cost of delay? Well, and just again, so everybody knows, what I'm about to run through is how I understand it based on listening to Don Reinertsen. I've read a lot of Don Reinertsen's stuff. I've watched a lot of his videos. Don is the Don of this stuff. So if you haven't heard of Don Reinertsen, and you're researching cost of delay, you've kind of missed the boat, because you really need to go read his stuff. He is the man when it comes to understanding cost of delay. So I'm going to try and do my best Don Reinertson interpretation here. So with apologies to Don for whatever I've screwed up. So the way the cost of delay is calculated is you're going to start with something that's called a lifetime profits curve. And the way that is calculated is, let's say that given, and I can't remember how these animations go, but let's say given a specific date, let's say we have a project or a product or whatever that we're working on. And let's say that it can be released by a specific date. In this example, we'll say January 1st. Let's say it's released on January 1st. Well, the way that you calculate this lifetime profit curve is, if the product is deleted on January 1st, we go and we calculate, we say, hey, over the lifetime of this product, if it's released on January 1st, over the lifetime of that product, how much profit is it going to make? What is the cumulative total of all the profit that it's going to make? And so in this example, let's say if it's released on January 1st, over its whole lifetime, it will make $1 million, right? Okay, so we put a dot at $1 million right there, just like that. And then you just do that same calculation for each subsequent day or each subsequent week or each subsequent time period that it could be released. You do that same calculation. So, for example, let's say, well, if instead of being released on January 1st, it's released on February 1st. And, the idea being here that if it's released a month later, that means obviously there's less time for it to make money over its lifetime. So chances are its lifetime profits will go down. And so now if it's released on February 1st, instead of making $1 million over its lifetime, it might make $900,000 over its lifetime, right? That makes sense. And so that's what you do is, for an arbitrary number of dates out into the future, you just kind of figure if a project or a product is released on this particular date, what might its lifetime profits be? And then you can draw a curve. And generally speaking, most products will look something like this. Will be this kind of reverse S curve type of thing, lifetime profits curve, right? By the way, this is no joke. This is how you're supposed to calculate cost of delay. However, this curve right here, it is important to note that this curve right here is not cost of delay. It is a lifetime profits curve. Be very, very clear. This is a lifetime profit curve. This is not cost of delay. But we can take this curve and we can calculate a cost of delay off of that. And the way that you do that is, everybody knows the old adage that time is money, right? Hopefully everybody knows that time is money, which also means that a change in time would equal a change in money. But for you engineers out there, this equation should seem fairly wonky to you. And that is because the units don't balance. We are taught as engineers to do something called dimensional analysis. And we know that we have to look, whenever there's an equation, we have to look and make sure that the units are the same thing. Otherwise, we end up slamming a Mars rover into the side of a planet, right? Mm-hmm. So units of time do not equal units of money, which means that we're missing some term in here. And that term is a partial derivative. I've only had one sip. One sip.
On camera.
On camera. The partial derivative of money with respect to time. Now, what does that mean in terms of our graph? Well, in terms of our graph, this partial derivative is going to be that term right there that I just showed you, is the very definition, is the kind of mathematical, rigorous definition of what cost of delay is. Pictorially, it is the instantaneous, if you will, the instantaneous change in money over time at any given point along this graph. That's literally what cost of delay is, right? So all of you out there might be thinking, how the heck do I calculate this thing? And that is exactly what Prateek and I think. Good luck. I don't know. Don definitely does have some ideas in terms of how to do this. For us mere mortals, I don't know. I'm at a loss. Good luck. Like I said, go read up on Don. Have at it. But this is, when we say cost of delay, this is specifically what we mean. And the reason this is important, because what Prateek and I are going to talk about here in a second, is it's very, very dependent on this exact definition. Now, so that's the bad news. The good news is you don't really need to know this math, right? You just really don't. There's a much better way, I think, a much better way of thinking about cost of delay. And that is just in terms of a high level definition. And Don Reinertsen gives us a couple of these definitions, right? So you can think of cost of delay just in words. Cost of delay is the amount of decrease in cumulative lifetime profit due to the delay in the introduction of an item. Hopefully that's what we just showed on that graph before. Or, this is probably a better way of saying it, the lifetime profit of an item is dependent on its availability date. And cost of delay is a measure of the rate of that dependency. So what we're saying here is, if there is a delay in the introduction of an item, a product, a project, whatever it is, a feature, that obviously, any delay in the introduction of that item is going to cause some type of change in its lifetime profit. And cost of delay is the measure of that rate of change, right? Here's kind of probably the most formal kind of definition of cost of delay, if you will, and that is, it's an economic framework to discuss the trade-offs associated with starting work at different times. All other things being equal, and this is, by the way, this is my emphasis, not anybody else's, but this is my emphasis. All other things being equal, value is maximized over the long run by minimizing cost of delay. Now, a lot of people, I'm stealing Prateek's thunder here. I said, hey, Prateek, make sure you say this, but I'm going to say it myself. A lot of people will say that value and cost of delay, are synonymous. That's technically not true, but they will use value and cost of delay in the same breath. And while that's technically not true, it's a good enough approximation that you can do that. But just know, really what we're talking about is, if you minimize cost of delay, then you're probably going to maximize value based on the economic description that cost of delay gives us. So I've waved my hands a lot there, Prateek. What else can you join in? Before we move to the next thing, what else can you say about this?
I mean, and I've seen you do the math of this multiple times. So there are so many things that are very interesting about that curve you showed, which is that cost of delay changes at every point as you move in time. So it's not only hard to approximate that curve, it's also hard to, because, well, you're approximating the curve and then you're approximating the cost of delay because you're approximating that. So if you can know this curve, great, you can figure this stuff out. But knowing that curve is the hard part, and simplifying this as you went forward with it, which is, at the end of the day, what you're really doing is finding a better economic framework rather than just trying to estimate value. At the end of the day, that's what cost of delay is trying to do for you.
Right. We're trying to make this, just like most things that we talk about, we're trying to make these conversations much more objective than subjective. Right. But there is real math or maths behind this. It's not just some, fancy, there's, like I said, there's a real rigorous definition that most people, I don't know if they know or they don't know, but they choose to ignore. But this is literally, when you say, hey, we're doing cost of delay, well, guess what? If you're not doing this, you're not doing cost of delay, right? You're just not. So, that's maybe a good segue into, you started to touch on maybe some of the problems of cost of delay. Do you want to say a little bit more about that, or should we talk about more how cost of delay is used first and then talk about problems?
Yeah, I think let's continue the thread of, let's find out how people use it in day to day, and then, yep.
Well, go ahead. I mean, that's your cue, isn't it? That's. There's Nisha.
Yeah, she was taking a scratch break there.
As everybody knows, Nisha's the real star of the show.
Yeah.
Everybody just tunes in for her.
But that's where so most people, since people equate cost of delay with value, or sort of have that, use cost of delay as an approximation for value, the next place people usually go with value is to figure out return on investment. Right? Your value is your return. So how much investment are we making to get that return? There's a more formalized version of that within this, which is CD3, which is cost of delay divided by duration. And you will see a lot of places, especially weighted shortest job first being a primary example of trying to do CD3. And I'm emphasizing trying.
All right, so let's unpack that statement again, because Prateek, for those of you who are familiar with our show, Prateek loves to shove about 20 minutes worth of video
Yeah.
into 2 minutes and 18 seconds of talk. So let's unpack this further.
Yeah.
What you're talking about is, generally speaking, the way that this used is, in our backlog or in our portfolio or in whatever, we have multiple items, multiple candidates of things that we could be working on.
Mm-hmm.
And so we're trying to decide what we should be working on, and more importantly, probably the order in which we should be working on those things. Okay. So explain what is this weighted shortest job first thing that you said, and how does that help us with this order and priority thing?
So, as we said, what we're really trying to figure out is what is the right sequence in which to do these things. One of the ways, not to directly pick on safe, but to pick on safe, one of the ways, like for example, SAFe, which is probably the most popular scaled agile framework out there, is it recommends you do it is by using something called weighted shortest job first, which, without getting into how we calculate it, is let's find out how valuable this thing is, and then divide it by how long it will take. So find out value divided by duration.
Yep.
Things that have the highest value to duration ratio, in that case, in weighted shortest job first at least, are the ones we should be doing first, because these are the ones that will get us to most value as quickly as possible. So that's what WSJF is, which people will tell you is a replacement for CD3, which is cost of delay divided by duration, because they sort of look similar, but I don't necessarily think it is. And we can talk a little bit more about that later too.
Yeah. To be clear, I think what you're talking about, and maybe not, but there is a formula in SAFe for weighted shortest job first. There's a formula. And I believe Don Reinertsen is on record, and please, again, forgive me if I'm misquoting him or whatever, but I believe he's on record for saying, there's this thing called weighted shortest job first and SAFe and something around cost of delay, but for all intents and purposes, that SAFe equation is not weighted shortest. I mean, it might be some approximation, it might be something else, but it's definitely not cost of delay in terms of a weighted shortest job first.
Yeah, I remember hearing him at some point saying, cost of delays units are time by money. Cost of delay by duration.
Other way around, right?
Oh, sorry, money over time.
Yeah, how many have you had?
I wasn't drinking off camera either. Money over time. And cost of delay divided by durations, units are money over time square. Fibonacci divided by Fibonacci is not any of that.
Yeah. So CD3, so just to be clear, CD3, when we say CD3, cost of delay divided by duration, or CD3 for short, is an actual implementation of weighted shortest job first that uses cost of delay. Now there could be I suspect an infinite ways to do a weighted shortest job first. It's just usually when we talk about cost of delay, the algorithm that we're going to use for weighted shortest job first is something called cost of delay divided by duration, or CD3. And that's where what Prateek said is we are going to take the cost of delay, we are going to divide it by the duration, the cost of delay for an item, divided by the duration, how long we think it's going to take for that item to complete. And that ratio, being able to compare those ratios for various different items, is going to give us an implied order in which we should be working things to maximize value over the long run.
Yep. It's just because you have cost of delay, it doesn't by itself tell you what to work on first.
Well, so Prateek, I mean, this all sounds great. I mean, we've got an economic framework, we've got all this kind of math associated with it. We've got very rigorous definitions of what cost of delay and weighted shortest job first and CD3. I mean, what could possibly go wrong? Why Why are we dedicating a whole video to this?
Yeah, this has been a theme of all these videos at this point, right? It's like, just because you did math does not mean you're right.
Mm-hmm.
Now, to the credit of cost of delay and CD3, if all the assumptions behind them hold, I have absolutely no argument. I have absolutely no way to say that this does not work. This is the best way I've seen it, if all those assumptions hold. The problem is there are some assumptions that are really hard to kind of make hold. We touched on one of these already. Exactly figuring out what that curve looks like is hard, because what we're really saying by saying we know exactly what that curve looks like is that value of any feature, product, project, whatever you want to call it, is deterministic. We can ahead of time exactly say how valuable something is going to be. I haven't seen much of that. I mean, I have seen a lot of people fail at making high value propositions and then completely losing, but I haven't seen a lot of determinism in value.
Yeah, I mean, that cannot be overemphasized as far as I'm concerned, is because we've got this product or this feature that we're trying to launch, and it may be, days, months, weeks, maybe even years before it's launched, and we're saying we know before we start this thing. Remember, this is when we're talking about ordering, the order in which we should work on these things. So we're saying before we even start on it, that we can know when it's launched, this is how much value this is how much lifetime profit it is going to.
I think it's worse than that, because not only are we saying that when we launch this on January 1st, it will have this much value. We're saying we know exactly if we launch it on January 1st, it'll have this much value. January 2nd, it'll have this much. 3rd, we know the lifetime profits on all those dates.
Right.
And I just don't think that has proven to be true. And there might be cases where it is. I just don't know of a lot.
Right. So that's the numerator. So we really, so remember, we're talking about CD3, cost of delay divided by duration. So the numerator is saying, well, it's difficult, if not impossible, in most contexts to even know what that numerator is. But Prateek, of course, we are so much better at estimating duration, right? I mean, we know what that denominator is, right?
Yeah, to code the numerator is really what matters. But
dear God.
Denominator. But that's the thing with I think we did a couple of videos at least where we talked about scatter plots, and we talked about Monte Carlo simulations, and then there was probably one in the middle where we talked a lot about probabilistic thinking, which in itself tells us that there are so many options in terms of how long something can take. Each of those possibilities has different probabilities, and we cannot just fix one number in that denominator. There is such a list of different amounts of time. If we're talking at the story level, we have teams that say a story can take 85% confidence, 20 days or less. It's 20 days or less. There are 20 different options there, and it's really. I think it's unjust almost to say we're going to pick one of those options and use that as a duration. In fact, I think when we did the Monte Carlo one, we didn't get into it, but I'm gonna attribute the quote to Frank Vega, but because he's the one who showed me this first, was what's most likely when you do Monte Carlo simulations and you come up with all these options, the one that's most likely is not very likely.
Right.
You run it over for whatever number of days, and the one that's most likely has a 7% chance of success.
Right. You're kind of building. I don't want to spoil the punchline because I know you're kind of building up to something. But again, just to reiterate, so there's a whole bunch of uncertainty in the numerator. There's a whole bunch of uncertainty in the real world, in the denominator as well. So we're starting to uncover what we're talking about is assumptions behind cost of delay, especially cost of delay, CD3. Oh, so in order to do a proper CD3 calculation, it's assuming that you know what the denominator is, which we don't. It's assuming we know what the denominator is, which we don't. What else is it? Is there anything else that it's assuming?
I think you said denominator twice, but yeah.
Did I? I might have.
But yeah, so let's we've already talked about how the numerator is super variable, the denominator might be super variable. There's a third thing which we tend to ignore with CD3, which is something that almost every company, organization, team faces every day, is that we know all the options that we have and no new options are going to show up. We've set the plan for the next 6 months, so nothing's going to change. So we can calculate our CD3 based on what plans we have right now. And it gets invalidated as soon as those new options start showing up. As soon as a new request comes in, which says, hey, we have all these new regulations because this new thing passed, and if we don't comply with them, we're going to be fined.
Yep. So yeah, if we can wave our hands a little bit more, let's say that we have 3 options that we're trying to choose from, A, B, and C. And let's say that we run CD3 calculations for all 3 of those things, and it comes out that the order should be CBA, right? That we should do them kind of in reverse order, CBA. So what Prateek's talking about here is we start C. Our cost of delay calculation said we should start C. So we start C, right? And now all of a sudden, while we're doing C, option D shows up. So of course, when option D shows up, we need to run a calculation, a CD3 calculation for option D. And now the question becomes, well, what if we run the CD3 calculation and it shows that we really should be working on option D instead of option C? Do we drop option C? Okay, so we drop option C and we start option D. And then option E shows up, right? And now we run the CD3 calculation.
Right.
It says we should be starting option E instead of option D. Do we start, right? And so you can quickly see that, number one, you can get this endless loop where nothing ever gets done. Maybe this sounds familiar. Or we need some way of handling the case where new items show up, because just because we think we initially optimize value by doing CBA, we live in the real world. New things are going to show up. How the heck do we handle the case when new things show up? CD3 doesn't, in and of itself, does not necessarily talk about that.
Yeah, CD3 might be an instrument that helps us talk about these new cases, but it doesn't solve it. Although, again, as we were talking about earlier, it is very prone to error biases on both value judgments and duration judgments.
Right.
Say, are we actually going to are we actually going to have the value we thought we will, and is it actually going to take as long as we think it would?
Yep. So this actually represents the bulk of what we really wanted to talk about in this segment, because I think, not that this hasn't been interesting, but I think the really interesting bit comes up here in just a second, or it'll be in the next video. It has to be in the next video, otherwise this video would be 2 hours long or whatever. But what I kind of want to end note this conversation with is, when you're talking about things like cost of delay and CD3 specifically, there are certain assumptions that you have to be aware of. There are certain assumptions that are baked in, whether you know about them or not. There are certain assumptions that are baked in. That value is not deterministic, duration is not deterministic, no new options show up, right? Those assumptions are there, whether you know about them or not. Now, the interesting thing is, none of those things by themselves are necessarily fatal, because we actually have tools and techniques to deal with that uncertainty. We have tools and techniques to deal with the fact that value is not uncertainty. That value is uncertain, that duration is uncertain. We can run things like Monte Carlo simulation and do things like that. So that's not necessarily where the problem comes in. It's part of where the problem comes in, but it's not not exactly. So don't think that just because we're saying you don't meet these assumptions that you can't use CD3. That's not necessarily what we're saying, but you're going to have to wait till the next video to see what we are exactly saying. So I don't know. Can you say that better? Can you sum things up better than that for me, Prateek?
Well, for me, I think I won't use my words. I would use the words of the most wisest sage of our times.
Of course,
Yeah.
Preach on.
Yeah. As Mike Tyson said so eloquently, everyone has a plan until they get punched in the mouth. That's kind of where, from a perspective at least, doing these calculations falls apart, is because you are essentially saying, I know that this is what's going to happen. I know if I release it on this date, this is how much it will bring in. I know that it will take me exactly this long to get this thing done. But that falls apart. Both those things are very variable, and the third one, that other things are going to come in. It's bound to happen. Other requests are going to come in. Yep. So you can't just rely on these decided calculations.
Right. So hopefully we have confused you thoroughly. When somebody says cost of delay, I want you to point them, not necessarily to our video, but certainly point them to the work of Don Reinertsen about a very, very rigorous definition of what cost of delay really is. Don't let some random blog post about SAFe dictate what you think cost of delay is. How cost of delay is used in terms of, ordering projects, things like weighted shortest job first, and specifically CD3. So we've talked, well, we haven't talked, we've waved our hands a lot about those things. And like I said, we've probably confused you thoroughly. In the next episode, what we're going to do is we're going to say, okay, now that we understand kind of the assumptions that are supposed to be in place to make things work, what happens when A, we model for that uncertainty, and B, when maybe those assumptions aren't necessarily in place? What happens in the real world, and what might be a good mitigation strategy for when we find ourselves in the very likely case that we aren't hitting all those assumptions, right? So I always like to give the very last word to Prateek, and usually Nisha, but it looks like she's got better things to do than to talk to us.
Yeah.
So please, last word, Prateek, for everybody out there.
And as Dan said, yeah, this could be a little heady, but really understanding what cost of delay is, how it's actually calculated, goes a long way in not allowing random people to come in and miseducate you about how to use these things. So hopefully next time we'll be able to take this a little further and give you some tools on how to use this appropriately.
Cool. All right. So for Prateek Singh, my name is Daniel Vacanti on behalf of the distilleries of Dalmore and Glendronach. We want to say thank you very much for joining us for this week's episode, and we will see you in the next episode. Have a good night.
Night.